Alright guys, let's get started. So, so far in the databases, what we've seen is that ever since we started using computers, we started putting our data on these computers. Earlier formats where we were putting it in files, and then those files could very soon go out of sync and not have consistency in their storage. Dr. Cord at IBM found out that if we apply set theory to these storage mechanisms, we can start storing information in the form of attributes, what we call column today, and in the form of rows. Dr. Cord laid out a set of 12 or 13 rules, and then scientists got ahead and added a couple more rules, and then they are now 200 rules. One of the rules is that to extract the language, to extract the data, there should be an English-like language, and then this language is going to help us extract data from another system called DBMS. A DBMS is something that sits in front of the data, the actual data that you store, and it has two activities. One is to prevent, and second is to provide the access. It makes sure that the data that is sitting behind is always prevented and protected. Our regular programming language is more instructive, that we tell it exactly how to extract information out. And then SQL programming language is more declarative, as you only tell them what information you need, where do you need them from, and what is the filter. And then the DBMS system, it goes and extracts that information for you. We saw scalars, which is a value that can be sorted. We saw non-scalars, which is something that cannot be sorted. So the trick in this case is that you divide them in separate columns. Point on the graph is a good example of this. When we talked about DBMS, how DBMS protects the data behind it and it restricts the access for the end user, and everything is routed through the DBMS. We saw a quick example of Docker, how Docker can help us save installation steps. Then we dived into the actual SQL programming. We looked at the DML, DDL. DML is select, insert, update, and delete. It is going to provide you access to the data. DDL is more about creating the data structures or laying out the format of the table. So we saw commands like create and alter. We saw a couple of constraints and how to link those tables together. Yesterday, we talked about the ACID properties, like how atomicity is, it makes each column a single consumable chunk of information. Consistency is across different instructions. The database does not go in an invalid state. It is the responsibility of the DBMS to make sure that the data is always consistent. Isolation is creating smaller chunks of data that is predicted by modifications on the outside when the operations are in progress. Durability is persisting data on the disk so that across restart and across crashes, we are not losing data. Then we looked at how, excuse me, then we looked at how data should not be stored as single value. It should be divided across multiple transactions, and these transactions with a particular date selected or applied, they can start making sense about the account history. So modification is a tricky operation, and you should do it in with a lot of thought in it. Right? Then we saw example of the database design itself, where we talked about the entity relationship diagrams. We discussed how to identify these entities, like members. This word is going to appear multiple times, and it's going to sound something important for the domain. And then if you read the English sentence of the project of the assignment, these sentences, they are going to come out. And one good way of translating this English sentence into the actual database or system design is that you start replacing common nouns with proper nouns. So member called and book a quote. You say Dave called and booked a quote from this time to that time. Information like this is going to help drive the conversation with the client as well. Then we looked at how how to separate out fact and constraint an example from a given mission statement. And then this is also going to help you identify the relationship and any constraints that are there in the system. Like when somebody says highest rate is something that they're interested in, it is because it is singular, it only has one entry. Had it been store highest rates, like store highest three rates, then you would have to have probably three rows or uh, mapping between two tables that is storing the three rows. So with that, we also identified some of the entity relationship syntax. So the parent element is going to have a little circle here. Well, if it is an optional relationship, we're going to have a little diamond here. This should be actually a dotted line. If you have specific cardinality requirement, like one tournament should at least have 8 teams as an IDL, you will put the number 8 here. And then you can get creative with it. Like if you want something between 2 to 8, you provide 2 to 8 here with hyphen. And then if you have more elaborate requirement, you can put them in parentheses, add a footnote, and then footnote is going to describe that situation. Okay. Then we looked at what redundancy is and what repetition could be. Databases are about storing facts and not about storing values. Once you understand that, each row is going to sound more like an English sentence. So when I have a table for members and it says names on one column and colors on the other column, it could be a red, like Dave likes red color. And then this thing changes our perspective on what repetition could be. Having red in these two columns does not necessarily indicate the deletion. We can go ahead and start replacing these hard-coded values or these actual values with their references in a table called color. But the way a red is repeating here, one is repeating on this side, and so we have not essentially solved the problem. We have pushed the data from this table to another table. We might have saved some space, but we might have the lookup is going to add some time to this particular thing. With that, we also talked about how we identify columns. So John has say 3 phone numbers and 2 email IDs. Now, if your system can work with 3 phone numbers and 2 email IDs, probably everything in one column is fine. But if you don't know how many phone numbers and how many email ID that person is going to have, then it is a good idea to extract out such columns and then make a separate table out of them and provide a referential integrity between these two tables. So the member ID is going to get used in the email table and email phone number table, and email is going to, and in that way we can establish a relationship as to which email ID belongs to which particular member. The entire database discussion relies on, or table creation thought relies on this one question here: how you want to use data. So we saw example where we are storing full name because we want to print it on top of an envelope. And in that case, these 3 columns should suffice. But then if you want to write a letter, you will have to divide full name into 2 separate columns like first name and last name. If you have more stringent requirement, you might have to divide your first name into the first name initial, which is going to become the letter D, and then you can have the other columns for the rest of the information. Depending on how you want to use your data, you're going to choose one of these 3 schemas, or you're going to divide your columns into separate settings. Then we also talked about normalization. Normalization is a technique where you pick up an existing table and then you start applying the normalization rules, which are called normalization forms. And then we looked at least 3 normalization forms. The first normalization form has 2 strict requirements: that it must have a primary key, and second, all the attributes should be atomic. That made us do 2 things to our member table, and then we added a primary key column. This primary key column could have been like our day one example where we had the first name column and the second name column added as a composite primary key. But then we added an ID column, which is primary key as it is stored in numbers. We also divided the address columns into multiple separate columns. So that is the first normal form. The second normal form is happens when everything in the first normal form is already taken care of, and when you have mapping between a, a member's primary key and a non-primary key member of a table, then you divide those two um, information into separate columns. You pull out the non-key member, you put it in a table of its own with the primary key of its secondary key here. So A is the primary key of this table, B is the secondary primary key of this table, and E is a member of the table. So you would extract out a new table out of this, making B the primary key in this table and E as the member, and you establish a foreign key. And once this happens, you can get rid of this column from this particular table. The second normal form says that, I'm so sorry, the third normal form says that everything the second normal form does or recommends is already taken care of, is done. So the data structure, the entity diagram is already in the second normal form. And then there are non-key members that are uniquely identifying other non-key members. So B points to E is the second normal form, and then B points to F is the third normal form. So in the third normal form, once again the strategy is similar, that you extract out F from this particular table, add it to a table of its own, and then you make the primary key as the non-key member of this third table. So once this happens, your data structure, your entity diagram is in the third normal form. Then we talked about denormalization. When you divide data across multiple tables like this, you will, in scenarios, will have to write join queries, and those join queries will give you a collective view of the system. There are two types of processing that you're going to do in databases. One is OLTP, online transaction processing, and the second is online analytical processing. So in the transaction processing, you're going to insert rows and create data structures around activities that are happening in your system, like somebody logged in. Excuse me, like somebody logged in, and probably there is a sale happening. Somebody places an order. There's an order that is shipped. Transactions like this, they fall in the category of OLTP, online transaction processing system. But then if you want to do analysis as to how much sale happened in this month, what is the highest product that is getting sold, stuff like that, they fall under the category of online analytical processing. Right? There are strategies, technologies for OLTP. In the SQL Server, there is something called as views, and then views take care of the OLAP part of databases. This is called the star diagram, if I remember correctly. So there is going to be a one centralized database or a table or a view, and then that view is going to have a lot of rows, millions of rows, and then it will be connected to separate tables or views in the system. So this is the star topology, and then on the OLAP side, there is a concept called OLAP views, and then if you've heard of technologies like Power BI, they try to extract out the data from the main system and generate this kind of reports. Right? So this is for the relational databases so far. Now we're going to move on to the next section of our course, which is the SQL. So what we saw so far is just one second. So what we saw so far in the databases world is that the data Give me 1 second, guys. Alright, so we have a customer table, and the customer table has a specific table structure. We are storing the ID, first name, last name, the address, and we have another table for the orders, and order has its own structure. It has an ID of its own, and it has a customer ID. So this two here, so this two here is actually representing this particular customer ID. And there is an obvious relationship between these two. In no condition, in no circumstance will have the flexibility of changing this thing, of changing the value that we store inside these columns. But then NoSQL is a little flexible in the way it works. So if we are doing NoSQL, our data structure is going to look a little different. So let me go ahead and draw the NoSQL equivalent of this thing. I'm going to put the customer keyword here once again, and this time I'm going to say ID colon 1122, and say the first name is going to be Sean, and the last name is going to be Smith, and address is once again 123 Main Street. Right? This is going to be the first row of the data. Notice that we do not have any column-wise structure. So let me add a second row to this thing. The second row for this thing is what we had in this database. We're going to repeat that, and then first name is Zia this time. Once again, last name is Khan, and this time I'm not going to store the address like this. I'm going to say that the village is Pune, and then state is Maharashtra, and my zip code is something. Alright, two rows of the same table, they can have different uh, number of elements inside them. So this is like the first condition, and then you might ask, you might be tempted to ask that, so what happens to these empty spots over here? The thing is that we are not going to have any empty spot. I mean, this thing is not going to be present in the first row itself to begin with. And then that is like the first point of NoSQL, that each row is going to have a different data structure. Make sense? So relational databases, they have a very stringent, a very strict requirement that the column and the data should always be in sync, and it should honor all the rules. So if we have a requirement here that this first name cannot be null, right? Then under no circumstance we are allowed to create a row where the first name is not entered. This is not null actually. The first name is not entered at all. But the NoSQL databases, they are a lot forgiving. They're like each row in the database, in the table, it can have its own data structure. Now, this is not something that you would prefer. You would have some form of structure to all the rows, but then you can accommodate stuff like address. In some places is called city and state. Then in some rows it is going to be village and say county and the zip code. There's not going to be empty space. There's going to be a lot more memory efficient. Now, where are we going to apply NoSQL? So there are specific places where NoSQL makes more sense. One is when you have, say, personalized information. Second is where you want to store, say, documents. Third is where you want to keep track of your connections, like the friends and the followers that you have, uh, it is a very good case of using NoSQL. And if you're making some random notes, they can become a very good starting point. I'm also going to show you a couple of examples later in the course where we are going to try and build a navigation bar of a website using NoSQL database. The second and so so this is, if not as compelling, then the second case of NoSQL should be very convincing. When you are building applications that are going to get scaled across the internet, so uh, in an enterprise application, when there are like 20,000, 30,000 employees of your organization, they are accessing the website. A relational database can take the load. And in scenarios where there are millions of users, billions of users that are going to access the site, relational database cannot uh, give that performance capacity. So in scenarios like this, if you want to write a query against a relational database, take multiple joins, uh, the response can come back in 1 to 2 seconds, and this should suffice for the kind of load that we have, for the kind of infrastructure that we have, and the number of users that are accessing these sites. But then when you are working at the internet level, and the industry word for that is web scale, when the application, the project that you are creating, is going to get accessed by millions of users, the performance requirement from the database cannot be this, right? It has to be sub milliseconds. It has to be less than milliseconds that you extract the data from your your permanent or persistent storage. And then relational databases, they do not give that performance to you. There are multiple reasons for that, and to understand this concept better, we are going to talk about a concept called the cap theorem. So a cap theorem essentially is three separate things. I can draw three circles on the screen. So there's going to be consistency in the first circle. Then we'll have um, and the third is availability, right? And I'm forgetting what this third is. I am assuming that it is reliability. So the relational databases that we saw, they have amazing consistency, and they have amazing. Um, okay, give me one second. All right. So yeah. So consistency, it means that the data that you are entering in the application, it is what it is. Let me take an example. When you have a business application, which is got a track of data between multiple locations. So suppose you have a server in Delhi for a very massive bank in the country. It is going to store data of the accounts and the customers that are there in the bank. Now, if this customer goes ahead and withdraws, say, $100, and somebody uses the same account or performs the same transaction and then deposits $200 in that account, when this operation is happening, the database, the DBMS, the database management system, is going to halt any operation on this particular, at least for this particular account number, across all the locations. So anybody who is trying to make the same transaction on the same database is going to be stopped until the new balance, say 1000, is reflected at all the places, right? And this is the role of relation database, that relation databases, they are going to make sure that the value is consistent across all the locations where this data is available. Reliability is that when this database goes down, for some reason, you're going to stop the entire system, and we're going to call it, say, a downtime, that the bank server is down and you will not be able to access it. So when it is up and in consistent state, but it is not always highly available. By high availability, what we mean is, as we are trying to enter $200, deposit $200 into this account, regardless of what is happening to this particular part of the world, this is say Mumbai, right? Regardless of what is happening on this part of the world, the data on this side or the server on this side will keep honoring the request, and it is going to let you make that update or insert in this particular part of the database. And eventually, the NoSQL DB is going to make sure that this data is moved to this part of the world of this topology of the database setup. Now, the word NoSQL itself is probably not correct. It is more than NoSQL. What it is trying to say is that it is a no relational database. So the relation between two instances of the database and two tables, it is very flexible, and it is okay not to have a very consistent. It is okay for the system to be in an inconsistent state for a while, and then eventually it is going to get consistent. Is it reliable? No, and not right away. But eventually it is going to give you reliability. And this is the CAP theorem is exactly this, that there are three attributes that you would want in a database. And any database management system is going to give you only two at a time. So when you are in applications like you are doing stock trade, you are doing banking, you will always have to go with relational databases, because they are going to provide you the consistency and reliability. Imagine somebody placing an order for a stock, which on this server says that that stock has already fallen. And then, because the data wasn't updated here, somebody went ahead and placed an order for 100 of those stocks and made a terrible loss. So in applications like these, where transactions are very important and consistency is very important, you are going to have to rely on the relational databases. But in applications where information syncing is not as important, NoSQL is a good starting point. And then those could be, say, Facebook, right? The example could be a newspaper. So the news that's getting published in this region is probably not as important for this particular person. Your own company's website, where you are listing down the products that you have, even if it takes a little while for these products to get propagate it for the data to come in sync. It is just that the users that are watching this site connecting to this particular server here, right, they're going to see a little delayed view. And that delay is not going to be as huge. It can be configured and you will eventually have that consistency. Okay, so that is the gap theorem for you. There's another concept that we should talk about now, and it is called the distributed architecture. When you are setting up a database system, you're going to have multiple DB computers, um, but then one computer at one point is not going to be enough. And the way you're going to do it is you're going to have multiple instances of this data divided across multiple DB servers, right? This topology is possible in all the DB servers that like relational databases and non-relational databases. There's a term called sharding. Now, sharding is a strategy of dividing the data. So if you have, say, 1 million rows, you're going to see that out of these 5 servers, I want first 200,000 rows on this particular database. Then the next batch from 200k to 400k, I would want here. The next batch goes here, the next batch goes here, and the last batch goes here. Now, what happens is when, for whatever reason, this database goes down, right? A relational database will have availability issue because the data is not present in the data for the last batch is not, the server is not available. And then this becomes your single point of failure. A relational database cannot tolerate such a thing. But then a non-relational database is a little forgiving when it comes to such sharding and division of data. It is just that this data is not available and it can tolerate that, can live with that, it can move on with the rest of the functionalities. This flexibility is not available to databases, and the important term that I want to highlight here was sharding. Right. Uh, Another difference that I would want to highlight at this point is the way we write queries. So in relational databases, we saw a very specific format that you start telling with the columns that you want to select. Then you tell it where that information is available, the table name itself, and then if you want to apply any filtering, you're going to put that filtering over here. So query in the relational database is a lot like English sentence, and it is declarative, and it's going to tell you that only the columns and that you need, and from the places where you need, and the filtering that you have. But if you have, but NoSQL is a lot like programming. In NoSQL, you are not going to have a structured query language. You're not going to have this particular syntax available anywhere. There are exceptions to this. There are SQL frameworks that are going to have SQL-like structure, and it is going to help you extract this. But NoSQL is more about programming and how to extract that information. And then one good example that I can give you at this point is census. So the process of counting the population, the people present in the country, is a census. And if we go back in the history of databases, where databases started for the first time, in the decade of 1800, when US first started counting its population, went through the census process, It took them about 7 years to get the data of everybody, of all the people in the country. And then they realized it became a law that I think it was year 1880, not 1800. It became a law that every 10 years the country is supposed to undergo census. So the next time it was lined up for the year 1890, and after this survey, they realized that when they start again after 3 years, it is going to take them about 11 years to finish the census process once again. The census that happened in India in 2011, I guess, uh, it took 20 lakh personnel from the government to just finish the census process. The reason I'm saying that, I'm sharing these two separate information, is because when the government realized that it is going to take 11 years, they'll not be able to finish the census before the next scheduled time of it, the year 1900. They started relying on computers and punch cards. So this was the beginning of IBM, where they started creating these drum-like devices, and these devices can process information based on um, in a document where they have punched hole and have written some names over here. So this was the first official usage of computers where they used technology to count the population of the country. And then when they came up with this machine in the year 1890, or the census for the decade of 1890, they did not take 11 years, they took 2.5 years. Right? So because of these machines, because of these punch cards, the way we were using computers and we were storing data, that thing has changed. But then, if you have some large activity that you want to perform, say you have a massive, um, you have a job as complex, as massive as counting the population of the country. You don't want to send like one person from house to house, from say top of the country to the bottom of the country, and then you count the people that are present over here. A good strategy is that you take this population and then you start dividing them into multiple areas, right? And this is, if you're familiar with programming, this is the concept of uh, setting, where or batching processes into smaller consumable chunks, and then you're going to identify these individual chunks and you're going to perform operation there. NoSQL query structure is a lot like this particular thing, at least in some cases. So what you do is you start dividing your work into multiple categories, and there are going to be multiple people who are responsible for each section. Now, the way it is going to work is all these 20 lakh people that are going to different areas that are assigned to them, they are going to come back with what they found in their area. So in area 1, they found out 20,000 people. Area 2, they found out 40,000 people. In the last area, probably say area number 1 million, they found out another 2K people. This step of SQL query is called as reduce. So you take a massive data at hand and you start dividing them into smaller consumable chunks, and for each chunk you create a separate thread, a separate activity that is going to perform its functionality on the given chunk that is assigned to it. I think I used the wrong terminology. This is not reduce, this is map, right? And once you have all these million rows, adding these numbers from these million rows is not a big deal, and then that step is called as reduce. So uh, a relation database would have not been able to perform this activity on its own because of um, the way data is structured. It cannot take those joins, it cannot perform query at this particular scale. And for that, NoSQL becomes very interesting. That It divides your big data into smaller chunks. It calculates it for those chunks, which is mapping, and then it uh, takes them to a centralized place, and on that centralized place, it is going to perform the final summation operation. And then in this summation operation, we are going to get the final result of a country's population, right? So uh, the queries in NoSQL, they are going to look a little different, a lot different in some cases than the relation databases. It is going to look more like programming assignment. Right. So let's move on to the next category. And there are at least four types of NoSQL solutions. Keep in mind. Alright, there are at least four types of NoSQL databases that are present. The first one is the key and value pair. So in a key value pair system, uh, we are going to have things like name is John, and we are going to be schema free. So each row can have varying number of columns, and there is no defined rule for this. It is not going to have any structure. So each row in a table is going to have its own data structure. Right now, generally speaking, there will be some structure to this. Um, like if you're storing order, it is going to look like order, but then the columns that it's going to have, it is going to be there's no rule that they have to match. So this is the first category of NoSQL databases, which is the key value pair. Now, another thing is that it does not have. Okay, you can put an ID column here, and then this ID column in some databases is going to become the standard for indexing. I'm going to show it to you in when we talk about the couch database. Right. The second category of NoSQL is a document store. The only difference between a document store and a um, key value NoSQL database is that everything in this particular store, everything is a document. Right? Every every entry that you make is going to be treated as a document, and once again, the similarity is that they are both schema free. The example of this particular uh, document store is MongoDB and CouchDB. We're going to see an example of the CouchDB very shortly. If I have to give an example of this technology, I'm going to say Redis. Redis is one example. Then there is another database from Amazon that is called Dynamite. If I remember the name right, it is called Dynamite. The third category is called the white column store. And inside a white column store, uh, you're going to have a little bit of both. You're going to have a little bit of structure, and you're going to define things like a column category. So there's going to be a super column, and then inside this super column, you're going to have another structure. And this structure can be a little forgiving, and you can have different name of column in a separate super column. This super column here is going to be defined. What goes inside it is going to be a little flexible uh, and something totally like once again no schema for what goes inside. So this is the third category, and then the fourth category is called the graph database. Uh, the way graph databases are different than all these others is because it is focused on the relationship. But then once again, the relationship is not like what we have in SQL databases or relational databases. It is more of a connection between two nodes. So suppose if this is me and I have 100 group of friends. So it is going to define a relationship like this. It is not a row-wise storage. Uh, if I'm friend with A, I'm friend with B, it is going to have that relationship defined, and what it stores is this particular structure and how this structure are connected. And once again, to define the structure, what goes inside this node, that is once again flexible. You can have any number of rows and any kind of schema, and then these two friends, they don't need to have the same information as well. Like this person has the about me, and then this person is going to mention where he works. So once again, the schema that we create for each particular element, it can be different. Make sense? The implementation for white column store is HBase, and if you have heard of the Facebook database called Cassandra, Cassandra is an implementation of white column store. And then for graph database, I have only used one technology so far, and that's called Neo4j. It has built-in features for storing NoSQL databases. All right. So let's go ahead and draw a key value store. So, so inside a key value store, the entire database is going to look like this, and the tables that we create, the tables themselves, they are going to have a very specific structure. So if we continue with our example of a customer, I'm going to come and put the customer name over here, and then the customer is going to have fields like ID and column. So I'm going to put a field called row ID, and I'm going to say 1. Then I'm going to say the first name is Zia, last name is Khan, and he lives in Pune. And so the last order he placed is order number 2000. So this is the customer table. The way we are storing customer is it has its own separate boundary, and it has its own rows and column structure. If I can go ahead now and create another table for the orders table is also going to be part of this particular database, and I'm going to add the order column here, and then an order is going to have an ID. Say that ID is 2000, and then the price of that item is $100, and it was, say, one laptop. So all the orders in this table, they need not necessarily look the same. Let me go ahead and edit this. This is order number 3000, and then let me go ahead and repeat this as well. So the second row need not necessarily share is structured, and then this is VR2, the order ID is here 3000. Now, even if you're looking at this data and you're seeing that here I see some structure, I see that they both repeat. Even if they are repeating, like row ID, first name, last name, the address, it is not a rule that they have to repeat. It can be different. Another observation that you can make, that all along we've been saying that NoSQL is not going to have any relation, but over here we have defined 2000 here and 2000 over here as well. So we can change color. This is each independent row of column. This structure is repeating as well, but then once again there is no requirement for that, and there is no referential integrity. So if I put the order ID 2000 here and there is an order ID 2000 here, it does not necessarily mean that when I'm inserting this value, the DBMS, the key value store itself, is going to go and check if there exists an order with this particular ID, and if it doesn't exist, it's going to give you an error message of failure. That is definitely not going to happen, even if we are storing information like this here. And that is what disconnects these two entities, and this is, in summary, the key value store for you. Right? If we can talk about the very close cousin of this, I'm going to copy this entire structure. I'm going to type wide column store. If you remember from our previous discussion, this is the third type of NoSQL database. Over here, okay, my computer is not responding. Over here, we're going to say that the only change we're going to have is, instead of first name and last name, we are going to say that there is going to be a name column, and inside name you're going to have additional information, and you can be a little flexible with this. Like, if you know that some countries, they allow they don't have one first name, they have two first names, like in Mexico. So the similarity that these two tables are going to have is row number 2. I'm going to have a bigger column, an outside column, which is a super column, and super column is going to sit outside. And inside this super column, this is the first name and this is the second first name column. Right? Let me pull that out. Okay. The second row of this database is going to have an outside column. So there is some restriction about the super column name. It can have a super column name outside, but then the inside of the super column is once again going to be disconnected. And you can once again have that relationship defined, that there is an order that this particular customer has placed. The order ID is 2000, but then there is no referential integrity check that if I enter 2000 here, there has to be an order 2000. So wide column stores, they are going to have a separate schema. The outside column name is going to be fixed. The inside of that super column is a little flexible, and that can change. Now, moving on to the third type of document store. The document stores are a little different. Another name for document store, if I remember correctly, is called the web database. Right? Guys, it is 9 o'clock. Let's take a quick break, and when we come back, we're going to resume our discussion on document store. Right? Okay. So let's resume our discussion on the on the document store category of NoSQL. Now, the document store category, they are also going to look a lot like the NoSQL key value store pair. It is just that instead of creating I don't know what is working a little slow today. Let me go ahead and do this. And right. So the document store is a lot like the key value store. The only exception is that anyway, instead of having these rows here, we're going to have everything here is a document. So instead of calling it a row, we're going to call it a document, and it's going to be a document for a customer. This customer is going to have sub-documents within it, and let me just go ahead and redraw it. So they can represent this thing. And maybe circle once again, right? There are documents that you're going to define in a document store, and then this document is going to be a customer. And then once again, we're going to have multiple key value pair fields here. And those fields, they are going to be the document ID itself, and we're going to give this an ID. We're going to have multiple columns like first name and last name, and it can have a smaller subdocument of its own. Another difference, another distinction with the previous key value store is that this time around, if you have an order over here, which is pointing to say order number 1000, this is actually going to hold a reference to a document in the orders table, right? And then this document is going to have that matching ID of 1000. And here you can track the rest of the information that I've bought a laptop for $300, for example. Right? So inside document store, you're going to have some form of linking between two documents, and then you can maintain that. Right? So document stores are a little different compared to the key value pair, and then everything is documented, and they can be versioned separately as well. So moving on to the graph database, then inside graph databases, we are going to track individuals, and everything is represented in the form of node. So a node here is probably going to represent my name, and then it is going to define relationships like an address, and then my address is another schema form thing, which is going to have my city, my zip code, probably a phone number to reach at. And then if I am putting a comment in somebody's post, I'm going to say that I have put a comment, and then comment is going to have a structure of that particular person, and the comment English language over here is going to sit with this. If I like somebody's profile picture, somebody's post, the like is going to be saved in a separate with a separate relationship. So the database is kind of going to grow like multiple connected nodes, and these nodes are going to represent how this particular entity is connected to all the other entities. Right? So with that, let's let's go ahead and start looking at the hands-on or the actual code of this particular theory. I figured that some of you are struggling with Docker. I generally don't like installing things manually myself, but then if, if you want, you can go ahead and run this query, download Couch DB, and then over here you're going to have multiple download options. If you install this, you're going to have a setup available on your local computer. In the documentation, there's a link for finishing the installation and setup. You can follow this document as well. Let me go ahead and share this link with you guys after our session. I'm going to send this to you after our session is completed. And right, so go ahead, follow through these documents. If you're on Windows, do this. It has binaries that you can download, and it is going to work. You will require probably .NET 3.5. I am generally more of a Docker person, and I do not like manual installations. So if you have Docker on your computer, all you have to do is go to another website and look for Docker Couch DB. It's going to take you to the Docker Hub page where all the binary images are present. And all you have to do is scroll down to a command, which is docker run -d, and then you select the database name or the image name. Now, there are a couple of properties that you will require, like the port. So let me go ahead and build the command in front of you. So the command is docker run. I'm going to paste the first part. I require this port, which is going to connect my host computer to that mini computer that we are creating. And then there is an administrator user ID and password that I'll have to give somewhere. So I'm going to say admin. And then this is what I know about the system. I had to read through the documentation. -e is the environment variable. The username is going to be admin, and the password is going to be admin. So this becomes the third part of my command, and then I use -d to run it in background as a daemon process, if you are familiar with the Linux operating system, and then I give the image name. So if you run this command, it is going to give you a Docker executable. While I was preparing for this session, I have already gone ahead and done that. So I'm reducing the font size, but then if I run this command is going to fail because I'm already using port 5984. So look here, 5984. I've already given this command. So I'll have to change something on my side. Let me call it 5985. And if I hit enter, it is going to print a very long cryptic number. And now if I run docker ps command, I'm going to see two entries. One is for 5985, which started like 4 seconds ago, and 5984, which started some 11 hours ago. Right? So this is how I start my Couch DB database. And then if I can pull up the documentation one more time, you're going to see that in the introduction section, this database itself is a lot about command line. So I'm going to jump to the tutorial section. There's a tutorial section. If I click on this link, after the installation is done, it is talking about the command called curl. And then it is also giving us an option of accessing it over the internet. So I am pretty sure that you guys know how internet works, but then if I copy this particular URL, and if you remember the output of the docker ps command, the port number 5984 is something that we have opened up. So if I open this link in the browser, call it this, I am being returned a JSON object. Right? This is not an HTML document, this is a JSON object. Now my JSON object is going to look a lot clean because I have a Chrome extension installed. If I click on the raw, chances are that when you enter this URL after your manual installation or through Docker, this same URL is going to return you this kind of data. I like my JSON to be clean, and that's why I have installed this. When I click on parse, it is going to appear a lot cleaner. So this is the first output that you're going to get when you run this command. But there is another way you can get the same output, and it is called curl. So curl is a Linux utility, and it lets you access the internet on the command line. So if I come and do this, it is going to return me this information. Let's try a couple more examples. www.microsoft.com, and find that. Okay, I did not get anything. I was hoping that it is going to print the HTML page for me here. But then curl is a command line utility that is going to get fetch like REST-like data, and it is going to render it over here. So this is the same output that we saw over here. Right? When I make it raw, it looks exactly the same. So you can access the couch database on the command line. So let's go back to the documentation and look at a couple of commands. So the next command is that it is saying that you can access all the databases. I have created it with the user ID and password admin. So if I come and copy this command and paste it here. Now this syntax is a little tricky. This thing here is the HTTP verb. When we are in the web API section, the development section, I'm going to explain more about this. But then get is requesting information from this particular URL. And then this information here is the user ID and password, and all DBs is requesting for a specific resource on this particular website. So when I run this command, it is saying that I have two databases. One database is called baseball. The second database is called hello world. Let me go ahead and compare this to our NoSQL application that we ran last couple of days. Right? So this is how we launched the SQL Server Management Studio. And then after I connect with the databases that I have in the system, they appear over here. We have worked on the demo DB, and then this is how the tables of a relation database appear inside the SQL Server Management Studio. Now curl is providing you that same option on the command line. So you will have to type this command up, and you're going to come back. The command is going to come back with all the tables that are present, all the DBs that are present in that particular DBMS. Let's go ahead and pick up a few more commands. The next command is, instead of get, it is doing a little put here. With put, if you run this command, this is how I created the baseball database. Right? I can probably change this to full stack dev, and if I hit enter, it came back with okay, true. Now it is once again equivalent of public. Clicking on this table here and saying that create a new table for me. Right? And then as you fill up these things and hit the save button, it is going to create that ID table. If I hit save, it is asking the table name 1. And if I do that and refresh this database, you can see table 1 over here. So the options that UI gives us, we have those options available to us through command line in such things in the couch DB. I'm going to pick up the next command. The next command once again is get. Now that we have added a new database, our output is going to look different. It is also listing the full stack there, the table, the database that we created using this command over here. Now, You can even delete the databases that you have, and for that, all you have to do is come back here and make that entry. So I'm going to type baseball here, and it is returned okay true. Let's go ahead and see if the database is actually deleted. And now that we run the all dbs command, it is saying that um, the, the baseball database has been deleted from what we had. So then this is going to get a little tricky here if you work on this thing like this. So there is another utility, and it is called as Foxon. So for that, I'll have to open up this link, and if I go to the browser and type this link in the browser, paste this link in the browser, it is going to come back with this page. The default user ID and password I've already saved, and now if I hit enter, it is displaying me a different uh, graphical view of the Couch database. So let's just walk through this UI for a short time. This is a lot like this data structure over here, this UI over here, SQL Server Management Studio. It has options for databases, it has options for setup, there are active tasks, configuration, replica, and then it has a nice handy link for documentation as well. We are concerned for our discussion with the databases section. We have created a full stack dev section here. So now let's go ahead and apply everything that we studied over here in these sections. That a database is going to have rows, and inside rows we can store different values. So I'm going to bring up the UI again, and notice that the terminology here is in sync with what we studied about the database itself. There are 4 types of databases: key value store, uh, large column databases, document databases, and graph databases. Because CouchDB falls under the third category, which is the document DB, it is going to give you terms and words like create a document. So it is not saying that insert a row, it is saying create a document. And then inside a document, the first element that it comes back with is the ID column. And then this ID has already been created for us. So let's go ahead and create something for our full stack course. So I'm going to call it say course name, and over here I'm going to say full stack .NET developer, and I'm going to say duration. Okay, when I type duration here, notice that the red line has kind of come up, and even before that, if you notice that there's a red line coming here, and it means the batch string, it is because of this little comma in the end. The comma indicates that there are more entries going to come after this. So we're going to come here and enter those 2 values. It's a key value pair. It has to go inside double quotes. It cannot by itself sit here like this, and duration is not a valid value. The keys, they have to be present in the double quotes. And the duration of this course is say about 80 hours. I'm going to put that number over here. Now, if I click on this button here, create document, these changes are going to become permanent. Right? Then notice that we have an entry, a document present in our database. Now, there are multiple views of this particular section. Let's talk about each of these separate. When I click on the table column, the UI has kind of changed, and it is showing the ID column here, the course column here, and the duration column here. Notice that there's one more column that we are seeing, which is the revision. We did not add this column. This column was added by Mongo because it is doing this document management for us. Now, if I switch to the metadata view, it is displaying the information a little differently, and the value is appearing over here in the JSON format. And if I click on the JSON, this is what I'm going to see. Now let's go back and click on this little edit button, and once I go inside, I'm going to see that the course duration is not 80 hours, it is 90 hours. Before that, let me go ahead and make a record of this particular revision. I'm going to save it inside Notepad, I'm going to call it rev1 equals cycles, just because, just to keep track of where we are coming from. Now, I've changed this 80-hour number to 90 hours, and I'm going to hit the save button, and notice that it has saved the information. And if I go to the metadata view once again, it is displaying that the revision has kind of changed. And if I come to the tables view, the tables view is displaying that it is a 90 hours course. Alright, this is our latest view into the system. If I go to the metadata, in the value, I'm seeing that for this key, the value is revision number 2. And if I go to JSON, I am seeing at least 2 entries here. The first entry is having a value of row, and the document itself is pointed here like this. And let's go ahead and copy this revision key and try to compare it with this value, right? So for the first, it was revision 1, for the second, it is revision 2, and this key here has kind of changed. Make sense? So every time you come here and you edit the document version is going to be maintained by the Couch DB database management system, and the information is going to be available to you inside it in this in a different format. Now, I'm looking for one more option. Right. So most SQL languages, NoSQL languages, they are not going to have database, but then over here you have an option of entering a query. But then these queries, they are mostly the selectors that you're going to provide, and then if you have specific requirement, you can come here and enter those values. Now I am not sure what is going to go here. I'm going to try EQ, and for the column type, I'm going to say rows, and let me look at this value. Instead of ID, I'm going to select course, and instead of greater than, I'm going to have equal, and over here, I'm going to provide equal stack developer course. And now if I run the query, I came back with the matching value. So if you want to apply some form of filtering, the way we had where clause in the relational database, you are going to have to provide a selector, and then if you notice the word, this word is the same as what we use for CSS. In a document, you are providing selector, and the selector is getting filtered on the property course, and it is doing an equality comparison with this particular thing. I don't know if there is something called as like. I'm going to put .NET. Right. So this is an invalid operator. I don't know what is the like equivalent, but if you go back to the equal condition, it is going to work. Once again, coming back to our structure, notice this button here. It is called upload attachment. And once I come here, I can pick up a file on my local file system, and then through that file system, I should be able to create an attachment. Let's attach the SQL example from our previous post, and then once I hit the upload attachment button, this document is added to the solution, and notice that the revision has also changed. Right. So this number, with every save, with every update, it is going to keep updating, keep revising, and then there's a new option that we are seeing here. It is called view attachment, and if I click on this, I'm sure that it is going to download that document for me. Alright, the changes tab here is going to show how many changes have occurred, have happened in this system so far. And Using the sequence numbers, you can filter out and figure out what changes the system has already gone through. Right? I'm looking for another link. So there was an option. Right? I was looking for this particular option. Notice that it is once again the CouchDB, and then we have our database name here, which is full stack dev, and then this is the unique identifier of the document that we have been modifying so far. Once we hit this particular URL, it is always going to come back with the latest revision, which is the third revision, and it is displaying the most recent updated information. And it also points to the attachment. The attachment name itself is SQL example.sql, and using this particular link, we should be able to download those documents. What I wanted to do for our session was try to consume this particular thing inside a REST API, but that demo for some reason is not working for me. So let me go ahead and probably create a base for our session for tomorrow. I'm going to come here. I'm going to save a new JSON file, and I'm going to call it. Save it on the desktop. I'm going to change the type of the file that I'm creating to JSON, and I'm going to call it navigation.json. Now, when you're working on complex applications, complex development projects like Amazon.in, this data that is coming here, you need not always have it hard-coded into your HTML. This navigation bar, it should be generated, if I was developing it, it should be generated on the server, and the server comes back with all the links. Now, if you remember from our jQuery session last time, let's pull up the jQuery cheat sheet. It has multiple options, including an option to do some Ajax and extract data from a server URL. So we're going to use this, and it has options for manipulating the DOM. So in the DOM, it can at runtime append elements. So let's see what that append code looks like. To append something, you are going to require an HTML to begin with. So let's go ahead and create our website over here. And I probably don't want to do this right here. Let me go ahead and create a, let me go ahead and open a folder. You can call it navigation example. Select folder. Now I'm going to add two files, index.html main. I'm going to call it index.html, and I'm going to add another JavaScript file, app.js. Let's insert some quick code here. This is Emmet. Those who have not followed the HTML code so far, you're going to see this in the recordings that I'm going to share with you. Over here, I'm going to say navigation example, and let's go ahead and add jQuery CDN link. Give me 1 second, guys. Right. So this is the minified version. I'm going to copy that link and add to the head section over here like this. Once I hit the save button, this has been added. In the body, I'm also going to add the script that we are creating. That's our C equal to app.js. And my whole objective for the rest of the session is to create this jQuery component that is going to add elements to our code dynamically. Sorry. Okay, so let's go ahead and start our live server. I'm not seeing that extension. It has done that to me earlier as well. And then my quick fix to that is come here to disable it, reload your application, and then enable it again. Live server is here, and I'm going to enable it. So once I enable it, I start seeing the go live button. We'll close out of this, and over here I'm going to press go live, and then we are seeing the greeting and the hello goodbye message from our HTML. So this is good. Now we're going to jump back to our this section, and we're going to append a child in using this little bit of code. So let's come back to our JavaScript file, and we're going to paste only one quick single line, that dot inner dot append, and then we're going to append a paragraph text. As soon as I save this and go back to our HTML, notice that this test is added to both the div. Now we don't want multiple sections, and we don't want the paragraph tag. If you remember how we added navigation to our earlier solutions, inside body we had a header section, inside header we had nav, and inside nav we had multiple UL and LI elements. So this is how our navigation looked like. But then I don't want to generate these LI elements through code, hard-coded. I want to generate these LI elements using jQuery. When we are in week 3, we are going to have a very good luck in we don't even have to write so much code. Angular and React, they are going to take care of most of this work for us. So I've copied the class name. I've added a class name here called navigation. Now that we know that this structure is working, we can build something on top of this. This time, we are not going to use the inner class. We're going to use the navigation class. Instead of C, we're going to use li. Make sense? Then first navigation link. Alright, now if I run the code, the UL and LI is kind of getting added, and our default section is already present here. Now I don't want one link in my code, I want at least 5 links. And then when you have multiple links that you want to add, you would probably want to use a while loop, and in this while loop you would require a variable. X should be less than 5, and I am going to increment the value of x every time. If I save this, so it starts with x equal to 0, it is going to add 5 separate elements to this thing, and over here I can add x here like this. Okay, what is it? Okay, so I need a plus sign here. So we started with an English, with an string literal. It is first navigation link, and we add x to it, and then we add the next element to it. So this should add at least 5 links to our solution. Right? Now, if we apply the Bootstrap knowledge that we have, so let's go to Bootstrap, CDN link, we'll need that. I'm going to copy the Bootstrap. I don't want version 5, version 3, Bootstrap 4 CDN links. And I come here, the CSS. I'm going to copy the CSS. And then some of you have ran into the issue of um, of JavaScript when you are working with Bootstrap, I would also recommend that you copy this section of JavaScript and have it added to your script section. So with that, you're going to have the entire Bootstrap effects, the one that comes with click of a drop down button and then how the hamburger menu pops up on the right side when you go to smaller devices. For that, you will require some of these scripts as well. So we have pulled the CSS style sheet and we have also pulled the script over here. Now we know that we are dynamically able to add links to our header section, but then our header section is not as neat. So we're going to save this information somewhere in the body, and we're going to replace the rest of the code with leaving the app.js alone. We're going to replace the rest of the navigation code with our default navigation. So I'm going to come over here and inside navbar, that's what we have to select. Right. I like this navigation bar a lot, so I'm going to copy this, come back to our code, and inside the body, I'm going to simply paste it, and my entire navigation is added. But then notice once again that these UL elements, uh, they kind of have the li and a tag inside them. I don't want them. Right? This is something that we want to generate using our code. So I'm just going to delete that, and I know that we have a navigation class created here. I'm going to change that because there appears to be some conflict. I'm going to call it instead of ID, instead of class selector. This is probably a good time where I'm going to switch to ID selector and I'm going to say top navigation, top nav bar. Right, let's delete this and I'm going to modify this particular UL element. I'm going to call it top navigation. Let's just copy this, and because we have changed the selector, I'm going to have to switch from the class selector, which starts with a dot, and I'm going to switch to the ID selector, which is top navigation. Now I'm going to say, let's just clean this text a little, and we're going to generate those 5 navigation bars using this syntax. So it is going to be link 1, 2, 3, 4, 5 under the UL element that we have just added. And with that, if I come to the browser, I'm hoping that it's going to work. Alright, notice that our links are getting dynamically generated. Makes sense? It is not looking as neat because we did not add the a tag so far. And unless we produce the same structure, like look at these guys, they have an li item with these classes, and inside the li they have an a with this particular class. So let's go ahead and copy this section and come back to our JavaScript code, and in the append section, I hope you remember the syntax that we discussed some time back, which is the tick character, and it is right under tilde left to 1. Okay, this is not a single quote. A single quote looks like this. A tilde looks like this. I'm so sorry, this is a tick, and a tilde looks like this. What we have entered is a tick under the tilde sign. So once again, I'm going to add the tilde character, and what we copied from this section, the li and a element, I'm going to paste it here. Now the reason I'm doing it this way is because I want to have multi-line feature. I am not sure if it is going to work. I'm just giving it a try. So it is going to add 5 elements. I don't know if I can use X over here like this. So I'm going to try that as well. With this added, now if I go back to our browser window and see this, you see our home links are added. Right? So we are dynamically generating links just to make it appear a little bit like this. But I'm not happy with how everything reads home. And this is where our knowledge of another JavaScript concept is going to come in picture, and it is the object literal. Now, if you remember, from our earlier section. I'm forgetting the syntax a little, but then let me go ahead and try this. So what I'm going to do is I'm going to define the home link here, and it is going to be hash. The next element is going to be the about section, and it is going to be slash about. The third link is going to be login, and it is going to look like slash login. So for now, let's just live with this, and instead of looping on X, this time we are going to, let me add two more links. Login, and then look at your cart and look at the discounts that are available. So in the cart section, I'm going to have link as slash cart, and the discount I'm going to have slash discount. Now, if I can point this particular link with this particular Excel, it is going to come in very handy. I'm not sure if this syntax is going to work, but then let's go ahead and give it a try. With this, if we come back to our website, it is saying home and undefined. So this syntax kind of is not working. And once again, we'll have to probably get rid of home as well. We don't need that. So we're getting a bunch of undefined here. Let's go ahead and select the syntax and call about over here. So when we do this, it is displaying the value of slash about. This is the value that we want inside the hyperlink, right? This is not the text that we want to display. So I'm going to pick this thing up, and inside the ahref tag, I'm going to put that value. I'm going to do 2 plus, and this value goes between these 2 plus signs. And once again, I'm going to put some hard-coded text over here, which is going to represent the link. So that text goes here. Now, if you look at these values, it is saying link and not a number. But then notice that if I click on this, I'll be redirected to the about page. So I have fixed at least one of the issues. Not a number is not working. We're going to look at that real quick. So this is links about. Okay, because about is not a number, it is complaining. I want to put these constant values, and then I want to map it against this particular index. So let's go ahead and change that. And yeah, okay. So to have some link text, all right, so I am not able to fix this right now. It is not coming to me, but the note is that our links are kind of coming dynamically, and they are also pointing to the relevant URL. If we remove that hard coding, in a sense, um, if we remove this hard coding and if we can point to these elements, our UI is going to get dynamically generated. What I want is, the reason I'm showing you this is because CouchDB is an internet database. So let's circle back and go to the CouchDB UI that we were looking at so far. My objective to this exercise was that we create a document. You are not authorized, but we have been logged out. Now we log out. And then if I log in again. Okay, so I am in the database. On the full stack dev, what we have been looking at so far is the courses structure. Let's go ahead and create a new document. And this new document, we are going to have another document, and we're going to call it links, or I'm going to call it In the double quote, I put links here like this. I have to put a comma here to fix that second error, and I provide a value over here. So the first value that I want to provide is the home page. So let's change this links to home. The second link that I want to have is the about page. So it becomes slash about. The third link that we want probably is cart. It's going to look like cart. And the fourth link is going to be discounts, which products are available on discount. And then it is available inside the discount page. So we have 4 links, and then one link was probably log out or login link, and then we provide the login option over here. Okay. Now these 4 links, if I hit the save button, it is going to create a new document for us, and it has these 4 sections in it. What I want done is, if I come and click on the JSON for this is what I'm getting. Now this information, if I can consume in this particular website, I will have this document populated from that particular database. And I tried a couple of options. It did not work for me. Those options were from, if we go back to our jQuery sheet, they were present here. So we know that we can connect to the internet using Ajax and extract out complex information. So the function that we're going to use is jQuery.ajax. And jQuery.ajax is going to take a URL from us. So look at this particular section, this example. I'm going to keep scrolling down and notice that they have an option of providing a URL. And when that URL comes back, we're going to have a done function getting called. So I'm going to copy that code. I'm going to paste it here. And all we have to do is we have to change this particular URL with the navigation bar URL that we have. So if we copy this thing and paste it here, right, it is going to go and hit this particular URL, and when it comes back, it is going to probably, hopefully, show us a log in the console. It will say fetched data from CouchDB. Now, for some reason, my example did not work when I tried it yesterday. I'm going to give it another shot. When I come here, see, my navigation bar did not populate because I'm assuming that there's an error in the console. So it's saying that $.ajax is not a function. Okay. And why is it saying that? I have the jQuery CDN included, and it is jQuery 3.6, which is the latest version. It should have worked. Let's come back to our cheat sheet. So give me 1 minute while I resolve this. Okay, probably the CDN reference that we added for jQuery is not correct. So this article here confirms that we are using a slim build of jQuery, which would have some issues. So we're going to fix that. We're going to add jQuery CDN, and this is still just a trial. I'm going to use the uncompressed version this time. Hit the copy button, and in the script reference for the minified version, we're going to replace this script tag with the new script tag that we just copied. So it does not have any hyphen min.js in it. And I'm hoping that with this, it is going to work. Alright, so it came back probably with the same error. Alright, I don't have a fix right away, but I don't know if this is going to help. This document got ready. But add fresh. Okay, so nothing is getting called now. Alright, I'm not sure guys what is wrong. I'll have to fix this. But I hope you got the idea. The way we are going to use CouchDB is we are going to create the entire website in this particular database in the form of multiple key value pair. Now, this is not enough, like storing home and slash like this. We'll have to figure out better ways of doing this, and I'm going to show that to you. But then we can store links in a specific document, which is for navigation. Once we have that document identified, we can reference that thing using the REST API point available for this. And then in this REST API, we are going to link it with our jQuery code. When jQuery code calls that, our collection is going to get completed. And when this collection is completed, we are going to dynamically add li and a elements. If this looks complex, I have not done much. It is the exact same thing that is present over here inside UL. I have only replaced here this thing is dynamic now, and the text inside this is a little dynamic. So with these two things added, your HTML code is going to shrink a lot, number one. Number two, it is going to be a little dynamic. So if I want to have, instead of 3 links, if I want to have 5 links, all I have to do is come back in this database here and remove that particular link. And with the JSON object with that same URL, you will, instead of 4 links, you're going to have, instead of 5 links, you're going to have 4 links. Make sense? Alright, so we are a little overclocked today. So I'm going to stop the session here, and